Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Counting Circles Tessellation by Chinstrap and Stream. And here are the rules. We have a tessellation where we need to fill each cell with a digit from 1 through 9, and cells sharing an edge cannot have the same digit. So for example, this cell cannot have the same digit as the 8 cells that it shares an edge with. This cell can't have the same digit as the 4 cells it's sharing an edge with. And that's an example of how that works. And each horizontal row in each vertical column contains a non-repeating consecutive set of digits, like 2, 3, 4, 5, 6 in any order. So every row and column has a Renban constraint to it, where basically they have to form a set of consecutive digits without repeats. And we also have counting circles, where a digit in a circle indicates how many circles contain that digit. So, for example, if this were a 3, there would have to be 3 total 3s in the puzzle. In the 3 total 3s in the puzzle in circles. In general, basically, just that there has to be 3. If there's a 3 in a circle, that means there's 3 total 3 total 3s in circles in the entire puzzle. And that's an example of how counting circles work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, how many counting circles are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There's 22 circles. Let's double check. 1, 2, 6, 10, 14, 17, 21, 22. Yep. So there are 22 circles, which means the digits add up to how many? They add up to 22, obviously. So, and we have at least 4 distinct ones. We could have an 8. That's possible. Unlikely, but possible. Actually, no, we can't have an 8. If we have an 8, the problem is it would have to be in every row except one, and this would be the one that it would not be in. But the problem is that means 8 would have to be here, which means 8 could not be in this row at all. So 8 cannot be included in here. Can 7? Maybe? We have at least 4 guaranteed digits. 4 unique digits, shall we say, guaranteed. Because there's 4 here, there's 4 here, there's 4 here. But we don't have to have more than 4. And we know 4 out of 5 of them can be in a set of 5 digits that are a Renban. If you have 4 digits, you can't have an 8 again, like I said, because you can't have an 8 in every row in a circle. You could possibly have 7. So one of these two would be 7. That means 7 would have to be in the remaining rows. And that seems possible. If you have, okay, so 7 in the columns. Well, don't you have to? To add up to 22, so you can't have 9, you can't have 8. That gives you 28 digits left, or 28 total digits from 1 through 7. So you have to lose 6. So you have to have 7 in every row. Or so you have to have 7 in the box because you're missing only 6 digits from the circles. So you're either missing 6, a 1, 5, or a 2, 4. So you're guaranteed to have 7 in almost every row. However, if this is 7 in row 1, that means you cannot have a 7 in the next row, which means 7 has to be in all the remaining rows. Same with this 7 and this potentially be 7. So that means you have to have 7 in all the columns. In every circle in the column, except for these two, this one obviously, and in every row except for this one and one of these two. So this is guaranteed to be a 7. This cannot be 7. This can't be 7. You can't have 7 in this row anymore. This can't be 7. So one of these two is a 7. Since one of these two is a 7, that means we cannot have a 7 here because we're guaranteed to 7 in one of these circles. So then to have a 7 in every column, this has to be a 7 because we are missing 1 here and 1 here. So this cannot be 7. 7 can't be here, so 7 in column 3 has to be one of those two. 7 in column 5 has to be one of those two. We're guaranteed no 7 there, so 7 has to be in column 7, one of those two. In column 6, it's one of those 3. This can't be 7. In column 4, it's one of these 4. Okay. So we also have a 3. Can we have 6? I guess so, maybe. We could have 6. So we could be missing 1 and 5. So these digits cannot be 7 through 9. Well, obviously the digits in circles have to be 1 through 7. The remaining ones here could be 1 through 6. So this has to be 1 through 6 also. One of these is a 7. So one of these is a 7, which means this is 3, 4, 5, 6, 7 at best. And this could be an 8 here. So 3 through 8. This also has to have a 7. This also has to have a 7. So this cannot be 1 or 2 here. So this could be 8, 3, 4, 5, 6. This also has to have 7. So to be a 5-length Renban with a 7, it has to be 3, 4, 5, 6, 7 at minimum. Oh, and 4 of those are on the Renban. So you either have 3, 4, 5. I think you always have to have a 3 in one of these. Right? I guess it could be... No. If you try to have 4, 5, 6, and 7 in the circles, and this being 8, 4, 5, 6, 7 already adds up to... Oh, you could be missing 1, 2, and 3. So it could be 4, 5, 6, 7. Huh. Yeah, it could be 4, 5, 6, 7. You're missing 6 digits worth, right? Yeah. So you're either missing 6, you're either missing 1, 5, 2, 4, or 1, 2, 3. So that is possible. So you're missing, if you have 4, 5, 6, 7, you're missing 1, 2, and 3 in the circles. If you have, you could either be missing a 4, a 5, or a 6 with the other ones. So it could be 7 with 3, 4, 5, in which case you're missing 6 in everything. So you're basically have to have a 1 and a 2 somewhere. You have to have a 7 in every row in this row 3. Because you have a 7 in one of these two. You have a 7 here, that's 2, 3, 4, 5, 6, and then 7. So this is at best 5, 6, and this has to be 5, 6, and 7. Because you can't have an 8 here in the circle. So this is guaranteed to be 5 or 6 here. So we have a 5, 6, 7 guaranteed. So we're either missing 2 and 4, or we're missing 1, 2, 3. So since we know we have a 6 in every one, we're missing a 6 in column 8, missing a 6 in column 9, missing a 6 in column 1. So this has to be a 6 here. So this is 6, which forces this to be 4 and 5. That means this cannot be 4, 5, or 6, so it's 3. So we are missing then 2 and 4 from the circles. Because we have 3, we have 6, we have 7, and we have 5 in the circles. That gives us 3, 5, 6, 7 is 21. We're missing, so we are just missing 4. So this has to be a 4 here. And this must be 3, 5, 6, 7. This can't be 3 because of the 3 in the row. This can't be 3. This becomes 5, 6, 7, which forces this to be 4. No 4 here, no 4. You can't have 2 in. This has to have a 7 and a 4. So this must be 3, 5, 6, 7. We're guaranteed a 3 in one of these circles. We're guaranteed a 3 in one of these circles, and we have a 3 here. So that eliminates 3 in the rest of the circles. So this can't be 3 or 4. No 2. No 2, 3, or 4. So this is 3. One of these is 3. One of these is 3. This is 5, 6, 7. This 6 eliminates 6 in the rest of the row. So 6 has to be one of these two. This must be 3, 4, 5, 6, 7. Actually, does it? It could technically be an 8 here. Or it's 3, 4, 3, 5, 6. It's possible. Actually, this can't be 5 or 6 because of the 5, 6, 7 triplet here, which shares an edge with this cell, so this is 3 or 8. In which case, this can't be 3. Because if this is either 8, which means this can't be 3 through 7. It would have to be 4 through 8. Or it's 3, in which case it can't be 3. So we have 5, 6, 7 here. 6 here. Where is the 6 in row 5? It has to be here. So this is 6, which eliminates 6 in the rest of the column. Where is 6 in row 4? It has to be here. So again, oh wait, we don't have a guarantee. We don't have a guarantee in rows. We have a guarantee in columns. We're missing 6 here, and 6 here. So the rest of the columns have to have 6. So this is 6. One of these 3 is 6. We're guaranteed 1 6 here. 6 cannot be here. We have a 6 here. Yeah, we don't have any guarantees in the rest of the column. Okay, 4 eliminates 4. Yeah, 4 can't be in any of the cells. So this is 4, 5, 6. So we're guaranteed 6 is one of those two, so this cannot be 6. This is 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 5, 6, 7. So this cannot be 5, 6, or 7. We could have 1, 2, 3, 4, 8, and no 9. This has to be, this could be 7, 8, 9, actually. So this is 7, 8, 9, with that being not 9. Or it could be 7, 5, 6. Hmm. One of these 3 is 7, so that's not helpful. One of these 2, 7. One of these 4, 7. This 6 eliminates 6 here. So if there's a 5 and 6 with the 7, 5 cannot be here because that would force this to be 6, but that's not possible. So this is 6 or 8. You could have 6 and 8 as a... This could be 7, 8, 9. Otherwise, if it's not, this is 6, 7, 8 or 6, 7, 5. We're guaranteed one of these 3 digits is a 1 or 3. In which case you can never have 9 there. I think that's the case. So one of these digits is 1 or 3. 3 can only be a 7-length rain band with 1 through 7, 2 through 8, 1, 2... Oh, it could be 3 through 9. Never mind. It could be 3 through 9. One of these is 6. One of these is 7. You could technically have a 1 here. Hmm. Hmm. We have a 6 here. 6 in one of those 2. 6 in one of these 4. 6 in one of these 3. 6 in one of these 3. Hold up. Okay. We are guaranteed a 6 in one of those 2. So rows 3 and 4. Row 3, 7, 8. 3, 4, 3, 7, 8. 3, 7, 8. And 4, 5, and 7. Not great. Okay. So if this is 8, 7, 9, this has to be 3. So then we have 5, 6, 5, 6, and that would be 7. I mean, this could be 1 and 3 here, though. That is part of the problem. Um, hmm. 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 Okay. One of these is a 3. That doesn't help. One of these two is a 3. That also doesn't help. If this is 1, that can't work. Because if this is 1, the problem is this would have to be 1 through 7 as a Renban. So that would force this to be 5. Well, okay, that still does. Okay, maybe that does work. That would force this to be 5, to be 7, to be 3. So you had a 5, 6 here. Oh, yes, and this couldn't be 5 and 6. Okay, well, in general, okay, so yeah, this cannot be 5 and 6 because that would eliminate all possibilities for that cell. So this has to be 6 and 8 or 7, 8, and 9. So this can never be 1. So this can never be 1 here. If this is 5, that forces this to be 6, and that eliminates all possibilities for this cell there. So this can't be 1, which means this is a 5, 7 pair, which eliminates 5 and 7 in the rest of the row. This can't be 5 or 7, it's 3. Which means this can't be 3, this is a 5, 6 pair, which eliminates 5 and 6 in the rest of the column. So this can't be 5 or 6, this is 7, which eliminates 7 here, and 7 here, and 7 here. Whereas a 7 in row 8, it has to be here. That makes this not 7, so it's 5, that's 6. This can't be 5, 6, or 7, so it's 3, which means this can't be 3. This can't be 3 here. This is a 5, 6 pair here in column 6, which eliminates 5 and 6 in the rest of the column, so this is 7, which means this can't be 7. So we have a 5, 6 pair in column 3, which eliminates 5 and 6 in the rest of the column, so this is 7. This 5, 6 pair eliminates 5 from that cell, so this is 4, that's 5. This 5 eliminates 5 here, so it's 6 and 5, which eliminates 5 here, so it's 6 and 5, which eliminates 5 here, so it's 6, which makes this 5, which makes that 6, and makes that 5. So this cannot be 5 and 6 because of the 5, 6 pair in the column. It's 1 and 7. That eliminates 1 and 7 in the rest of the column. One of these has to be 8, so this cannot be 8. We need a 4 somewhere. So this is 1 or 7. If it's 7, it cannot be with 6, so it would have to be with 8 and 9. If it's 1, it has to be with 2 and 3, so this would be 2 and that would be 3. So those are the possibilities there. 9, however, cannot be any of these cells. Okay, what does that tell us? I'm not sure. Anyways, these digits are, one of these has to be 4. So 1 is 4, and we could have 8 and 9 possibly. 9 cannot be either of these, so it would be 4, 8, and that would be 9 if that's the case. Or it could be 2 and 4, and that's 8. That's possible. Okay, this, no 9 is here, so we're guaranteed 3 and 2. It's either 1 through, so this can't be 3 because of the 3 in the column. So we have, yeah. It's 2 and 3 guaranteed with 1 or 8 here. We don't know which. So 2 is one of those 3. 3 has to be one of those 2. These digits are remaining. We have 1, 2. This 6 eliminates 6 here, so this is 8, which means this can't be 8. That's 9. So this has to be a 4, 8 pair to be a 3 through 9 Renban. This 4, 8 pair eliminates 8 here, so that's 3, which eliminates 3 in the column, so this can't be 3, this can't be 1. Where is the 3 in row 4? It has to be here. So that's 3, which eliminates 3 here, so this cannot be 2, 3, and 1, which makes this 7, 8, and 9. This 7 eliminates 7 here, so it's 1. This can't be 3 because of 3 in the column. This cannot be 1 because if it were 1, it has to be with 1 through 7. So this is 2 through 8. This cannot contain 1 here. So this can't contain 1, this can't contain 1. This must be a 2-4 pair because 1 can only be with 1 through 7 as a 7-length RAM band. So this is guaranteed to be 1. One of these is 9. Okay. So, we have 1, 2, 3, 4, 5, 6, 7. Sevens in circles. 1, 2, 3, 4, 5, 6. Sixes in circles. 1, 2, 3, 4, 5. Fives in circles. 3 threes in circles. 1, 1. If this is 8, if this is 8, this is 4. This is 8. Eight, 4, 8, 9. So if this is 8, this is 2. This is 4. This becomes 8 and 9. But then that would be 4, so that would be 2. So this would be 2, 2. So this cannot be 8. This is 2, which makes this 8, which makes that 9, which makes that 8. This is 2. So this has to be a 3 through 9 Ren band. So this is 4, that's 2. This 8 eliminates 8 here, so it's 4 and 8, which makes this a 4. And that's a solution for this. Yeah, it's probably a little harder than most tessellations, but it's still not really that difficult. I would put it probably in between easy and challenging. But I guess challenging can be fine since it's slightly harder than easy, I would say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.